Hi, welcome to Physical Science 4.3. This is an introduction to waves. So what is a wave? Well, a wave is a disturbance or a pulse that travels through a medium from one location to another. A medium is a substance through which the vibration travels. Could be air, liquid, water, solids even. Waves carry energy. The first kind of wave that we're going to talk about is a slinky wave, a longitudinal wave. In a longitudinal wave, the pulse travels in a direction parallel to the disturbance. The pulse travels parallel to the disturbance. This is squishing the slinky. Examples of longitudinal waves are sound waves and ultrasound waves. In the anatomy of a longitudinal wave, the open sections of the wave are known as rarefactions. The pressed together sections are compressions, and one compression and one rarefaction make a wavelength. Again, one compression and one rarefaction make a wavelength. The second kind of wave we talk about is a transverse wave. In a transverse wave, the pulse travels perpendicular to the disturbance. These are electromagnetic and even ocean waves. And in a transverse wave, the top point of each wave is known as a crest. The bottom point is known as a trough. The height of the wave away from the equilibrium or away from the medium is known as the amplitude, and the crest to crest or trough to trough, comparing any two similar points, in this case crest to crest, is known as the wavelength. So this is a slinky wave simulation.
In a longitudinal wave, the disturbance that makes up the wave is along the direction in which the wave travels. Longitudinal waves are also referred to as compression waves. In a transverse wave, the disturbance that makes up the wave is perpendicular to the direction in which the wave travels.
So to sum it up, a longitudinal wave is a squish of the slinky. It is the source moves left to right, the coils move left to right, the energy travels left to right. In a transverse wave, the source moves up and down, the coils move up and down. This is a wiggle, but the energy is still transported left to right. There are some wave interactions. Wave interactions occur in two times: when a wave meets an object or another wave, and when a wave passes into a different medium. There are four primary types of interaction: reflection, diffraction, refraction, and interference. Reflection is when a wave bounces off a surface that it cannot pass through. So the normal is perpendicular to the surface, and the incident beam is how the light or whatever the wave is comes in to the surface, and it is reflected at the same angle. A refraction is the bending of waves when passing from one medium to another. So if you are going from air to water, it will slow down, okay? The wave will slow down and it will bend toward you. But if you are going from water to air, it will bend away from you. Because it will move faster. An example is when you go fishing, the fish appears to be here, but is really down here because of refraction. Diffraction is the bending of a wave as it moves around an obstacle or passes through a narrow opening. An interference is when two or more waves combine in a region to overlap. And you have two kinds of interference. Constructive interference, where they literally add or combine their energies, and destructive interference, where they subtract their energies. Thanks for watching.